The straight line is the first opportunity really to introduce the idea of slope or gradient. So the simplest way to do that is to put a couple of points on. Let's put a point here and let's put a point here. Now don't forget we're snapping to integers, so it's relatively easy to do this. Select those two, it doesn't matter which order, so I can do a multiple select like that, and a right click. We can have a look at gradient. And that would put a triangle on here, and you can then have a look at see how steep it is. You can define its gradient as being the change in y over the change in x. So if I select this object and go to the text box, you can see that it gives me the value of the gradient. It also gives me the change in y and the change in x. Some of your students may not be quite ready for delta notation, but you can explain what it means. It's a convenient way of saying that. So this distance equals this distance, so the gradient is 1, so that angle is 45. It's quite a good idea to use the arrow keys now to move the points around, because it does so nice and deliberately. So we move 1 to the right, what's the gradient going to change to? If it moves to here, it's going to be 2 divided by 3, 2/3, or 0.6 recurring. What happens if we get closer? We can press Control and go up in tenths. So what's happening now is that the gradient's getting steeper and steeper and steeper. Till we get to here. Now I'm just covering out as 0.1. It's as close as we're going to get. So if I press that one as well, it will also go in 0.09, 0.08, 6.5, 4, 3, 2, 1. That's a gradient of 200. It's pretty steep. Now if we do one more, what are we going to hit? We're going to hit infinity. What happens if we go this way? You're going to get 0, and then down here you're going to get negative. So let's delete that and that one, and let's put on the most basic straight line that there is, which is, now if I extend this, I've got the full keyboard, and I'm going to press Y equals X. I've got in the habit of putting spaces in, it just makes it a bit easier to read. Okay, now if I press OK, what's going to happen? It's going to actually just draw it straight off, and I don't think that's a very good idea. So let me introduce you now to the slope plot. Slope plot is fabulous, because what this does, if you have a new page now, right click, enter equation, it'll be on here because we've just done it. This is the history. Y equals X. Now you can see that it's going along here slowly, so I can stop it and we can discuss. Get the pen out. Right, who can tell me some points that it definitely goes through? If Y is the same as X, then obviously 0 and 1 and 2 and 3. There's always somebody that thinks it goes up here, but perhaps the rest think it's... So you've got 1 point out of kilter. Let the brakes off and just watch it gobbling up those brown points, which is excellent. And you can always, of course, be kind to this one and say, well, actually, it's what you really meant, wasn't it? Okay, edit, select all scribbles, and delete. Now we've got y equals x, I'm now going to put on y equals 2x. It'll be going slowly, so there's time to think and stop and get the pen out. Well, it's going to have a point here and a point here. They're getting good at this now. And off we go. So that should gobble up these points. And what's clear is that we're dealing with a line that's steeper. And so if y equals 2x is steeper than y equals x, how does it all fit together? So let's do edit all scribbles and delete. I'd like to have some measure of how steep this is. We've already defined gradient as being the rise over the run, so I'm going to put a point on the blue line when x equals 1. So I'm going to select it and right click, enter point on the line, and at x equals 1. I'm also going to put a point at the origin. So if I select those two, which I can do like this, I can measure the gradient of that line as being that divided by that. Now notice I've got the status box up here. That's obtained by double clicking down here, and that's a nice way of showing not only the current object but the currently dependent object on that. So we've got this point here which is 1, 2, and the gradient which is 2. Now is it just a fluke that that number 2 is the same as that number here? So I'm going to double click on this and change that 2 to a 3. Okay, what's that going to do? Well, this point's going to move up to here, the line's going to get steeper. And the measurement of how steep it is, the gradient, has gone up to 3, so it's 3 over 1. So it does rather look as though the number here represents how steep the line is. If we made that 30, well, let's make it 30. Okay, so we'll change it to 30. And it's going to get a very steep line, but the gradient's 30. Let's go and find it. Let's wait for it to finish plotting. Okay, so let's go and have a look. And there's our line. If you wanted to, you could put just select that point rather and do a horizontal line through there so you can see. So what we could perhaps introduce them to, when you think they're ready, is putting a letter in here instead of the number. So I'm going to put a letter M. No one's quite told me why M is used, but it is. And as soon as you have a constant in this equation, you can edit them. So you definitely want to make that the same as we've just got, which is 30. So nothing's going to change, it's still going to draw the same line. We can fast forward this now. It's just that with the constant controller now, we can draw lots of straight lines. We can make M bigger or smaller. And what you'll notice, of course, and if we do the red tick, you can see what's happening. The red tick just sorts out the scales and brings you down to earth nicely. So I'm going to reduce this down, and you'll see that all that's happening is that this point is moving up and down this line here. Equal aspect doesn't get put back with the red tick, unfortunately, so we need to just do that, go down again. Now, this is where the constant controller really comes into its own. What we don't want to do is go charging through like this. So up and down changes the value, but left and right changes the step. So if I go back to 1 and then reduce the step to 0.1, this is going to come down here to finally we get to 0, and we introduce the idea of a negative slope. Obviously you can do the same thing with plus c. So it's a good way of introducing the idea of a straight line and its gradient. So let's have a look at the quadratic next. And in just the same way that y equals x was the grandfather of all the straight lines, y equals x squared. Y equals x squared is the grandfather of all quadratics. So once again, let's stop that, let's pull it down a bit, and let's put some points on. So where is going to be x squared? Now what you could do is do a table of values, x and x squared. If you do negative 2, negative 1, 0, 1, 2, x squared is going to be 4, 1, 0, 1, 4. So let's have a look at this. It's going to be 0, 1 is 1, 2 goes to 4, negative 1 goes to 1, negative 2 goes to positive 4. So it's coming down like that. It's quite steep, and let's take the brakes off and see if that actually works. Edit, select all scribbles, and delete. Okay, so having got that, let's have a look at the transformations of this. In the same way that we were transforming y equals x by y equals mx, I'm now going to do y equals a x squared. Now, a is a constant which will be take the value of 1 to start with. There it is, 1, so I'm happy with that, and so it'll just plot straight on top of that. Now the constant controller is fantastic because it will now enable us to animate this and look at different values of a. So I'll just go to that because that belongs to the previous page. So if I increase a, it's going to go in a step of 1 to 2, so that's going to become twice as steep. What does twice as steep mean when you've got a curve and not a line? Well, this point goes up to here, doesn't it? And this point goes way off the top, so it's a much steeper parabola. Let's have a look. There it goes. and we could bring this down to once again reduce the step. Now in the options here we've got the options to do a family plot or an animation. Let's do a family plot, and let's go from -3 tab 3 tab, let's do 0.25. Okay, and that'll produce lots of graphs in this region. There it goes. If we change that into an animation, up and down, you get a sort of flapping bird. Just press go, up we go. Okay, the next thing I want to do is double click on this and just put some brackets in here and see what difference that makes. Let's put an open bracket here and a closed bracket there. What difference will that make to that animation? Well, certainly it's not going to go negative at all, it's just going to go down to and up again. So yes, we'll do that. We can finish the plotting quickly and set it off again. That's a bit more like a flapping bird. Okay, now the next one is to change this bracket to x minus a. So they get the idea of the transformation. Now at the moment a is doing this pattern here, so you need to talk about this quite a lot. If a is 0, of course we've just got y equals x squared. If a is 2, for example, you've got x minus 2. When x equals 2, it has a 0 value. So when x is 2, the whole thing is moved to the right. So if we're animating from -3 to +3, notice this is x minus a, and that's, I think, always better than saying x plus a or even a minus x, because it means that when x equals a, if a is positive, this is translated to the right. So it's going to start off at -3 and go up to +3. It depends where it's got to in the cycle. It's got to -2.75, so it's going to be over here. Let's just see if that is indeed the case. We'll just finish doing that. There it is, -2.75, and off we go. Always try to anticipate the diagrams before they actually draw. The final one is to do x squared plus a. This is probably the easiest of the lot. X squared plus a. That's going up and down, again depending on where we stop. If we stop at -1.25, it's going to start down here and move up. Okay, ready, steady, go. So those are the various transformations of y equals x squared that they have to learn about. Next on to prepare them for a nice graphical exercise of fitting a parabola to some parabolic motion. So suppose we've got parabolic motion like this, going through the origin and going through 12. What form is it going to take? Now there's obviously several lessons in between what I've just done and this, but after some discussion you decide that it's going to take the form of this. Now is it going to be 12 minus x, or is it going to be x minus 12? We decided earlier on that if the coefficient of this is negative, or the coefficient of x squared is negative, then it's what we call a sad parabola. This is a sad one. This is a happy one. So it needs to be 12 minus x. So let's try that. Okay, so we just press enter for entering an equation. Y equals x, open brackets, 12 minus x, close brackets. Go right up into the sky. Now if you time it right, you know roughly when it's going to come down again. Now that wasn't quite right. What we've got to do is scale it vertically, so we need to put a constant before it. So let's put a constant here, let's call it a. Now a will be 1, so nothing's going to change, so we can fast forward there. But the constant controller kicks in, and we can now finish that one. We can now reduce a. If we reduce a down to 0, it's going to go straight down there, isn't it? So this is where it's really nice to be able to reduce the step and come down in bits. Now you're going to see how well or not I drew a parabola. reduce the step, and up we go. So I didn't draw it too well. But it'd be far better if at this stage we now get a proper diagram in. So if you look at TSM images, which you can download off the web, and have a look at parabolic, human cannonball, here it is. So just grab that and drop it on. If for any reason that doesn't work, you just do right click, insert image, and go and find it. So if you go to the desktop on my system and TSM images, parabolic, human cannonball, and there it is. So that's another way of doing it. Another way would be to go to the web, and this is the TSM resources site, and if you go to the autograph page, and under Douglas Butler go to TSM images, and here are lots of images that's fun to have imported into autograph, and the one that I'm actually doing is this one here. So literally right click, copy, and open up this page and right click, paste image. So we've now got it in 3 times by 3 different methods. So we can get rid of most of them because we only want one. Now the trick here is, first of all, double click on the image, double click, and give it some transparency. About 20% seems to work quite well. Now scale image with axes. I'm going to leave that tick just for now, and I'll explain what that's about in a moment. If you take the end of the gun and just move it to the origin, then this is the model we're looking at, and obviously the one we've discussed just now isn't quite right, but it'll do. Let's just move this up a bit and go back to select mode. Now if I want to rescale this so that it's more accurately fitting the dimensions of the picture, I would say that's probably going to be about double, and up here it's going to be about double. So I think I'm going to first of all double click on this and take this off. It's very important that if you're going to mess around with the axes, you take that off, otherwise the image is going to get all distorted. Now to edit the axes, you double click on the axis, and I want Y to go from -4 tab 8. That works quite well. I'm not going to bother with the X because I've got equal aspect on, and so the X is actually being determined by that rather than by anything I put in. So I'm going to click OK, and you can see that that's more like 12 meters actually, the one I was guessing earlier on. But we need to move the gun to the origin now. See, the picture has survived intact, hasn't been distorted or anything. I'm going to edit, select all the scribbles and get rid of that. Now this equation won't do. I need to double click on it and put a constant instead of 12. Let's put B. Let's make B, what should we make it? About 14. That would seem about right, but obviously we can fine tune it later on. That's not bad. So now we get the constant controller back and change B. A nifty way of doing this, by the way, if you're doing it all on the keyboard, once you've got the focus here, you can use page up and page down to change the constant. So if I want to change B, now I'm going to increase B a little bit, and then reduce the step and increase B a little bit more, and then page up and page down will change it to A. Now I'm going to reduce A, reduce the step a bit more, and that's pretty good. What this slightly foolish person needs to realise is that as soon as he's left the gun, his path is completely determined by his initial speed and angle. And there's nothing he can do. He can fiddle around with his stuff to make sure it doesn't land on his head, but he really is following this path what may. So if he doesn't get it quite right at the start and he misses the net, that's goodbye. Anyway, so there's a few ideas about using autograph to have a look at straight lines and parabolas.